So many of you have probably seen Interstellar and seen Matthew McConaughey travel through space and time and find himself on the other side of a black hole into this 4-dimensional realm.
Wow, that sounds crazy.
It's crazy. Recently, scientists were able to take the first picture of a black hole.
Oh yeah, I saw this on Facebook. Very cool.
Yeah. So just to preface this, neither of us are physicists or were able to understand the paper that they wrote about this, but we love science and the news, so we wanted to cover it as best we could.
Let's just start with the basics. What is a black hole?
A black hole is a place of what we call concentrated gravity. Around a black hole, it sucks in everything around it, whether it be matter, whether it be just particles floating around in space, and it even can suck in light. That's why it's called a black hole, because you can't see what's behind a black hole because just the light's just completely sucked away from this gravity field. Any movie with a black hole in it, people always end up dying and getting sucked. They have no idea what's beyond a black hole. It's probably not the 4D realm of Interstellar, though it's kind of cool to think of it like that. The big thing about black holes is that they are based off of Einstein's theory of relativity.
I've heard of that, but I can't remember exactly what it is.
Yeah, I think we all learned it in school and then it just kind of like flew over our heads. Before Einstein had this theory, Isaac Newton thought that gravity was a force.
Oh, this I remember, mass times acceleration.
Yes, and just where the apple's falling, it's a force that naturally happens based on Earth. But what Einstein argued was that gravity is a distortion of space and time.
That sounds like crazy talk.
And he has a lot of math like behind that. But it's not been until recent years that scientists have been able to prove a lot of his theories correct. About 2 years ago, they have found the discovery of 2 black holes coming together and kind of making this gravitational blip.
Wow.
And they were able to measure that.
That's
It was insane. And then back in April, when they were able to image a black hole and then discover that it's round and cylindrical, like how Einstein predicted it to be. Let's talk a little more about what a black hole looks like. What you can see, it looks like a black hole, and there's the kind of this red rim around it. The point at which light can't escape from a black hole is called the event horizon. That is kind of that red ring you're seeing around. This ring kind of glows red because when matter approaches the black hole, it heats up and generates a lot of friction and produces light. And so that's that round, kind of that round orange ring around the black hole. And this is what we see in the image. We're seeing this event horizon of the black hole. So it's kind of a misnomer to say, oh, we took a picture of a black hole. It's more of looking at the reflection of the event horizon, because the black hole itself there's no light coming from it.
So how does a black hole even form?
What can happen is we know things like stars and the sun can distort space-time if we think of gravity as space-time. If you imagine we have the sun, we have all these planets that are revolving around the sun, and it's always been said, oh, that it's revolving around the sun because of the sun's gravity.
Right.
And this is not necessarily true. It's more due to a space-time deformation caused by the sun that's pulling everything into it. A black hole can form by something having 0 volume, but having gravity. It's kind of complex to think about, but an analogy might make more sense. So if you know, like when we send rockets out from space, they have to reach a certain escape velocity. In the case of Earth, they have to depart at 11.2 kilometers a second in order to get to space. And this is because rockets need to pull away from the Earth's gravitational force. And the lighter, if you think about just the way gravity works and weight, the lighter something is, the larger escape velocity it needs. If you have a feather trying to leave Earth, you'd have to have it go really quickly in order to be able to pull away from Earth's gravity. Einstein's theory says that for something really small, the escape velocity can eventually reach the speed of light.
Okay.
And when it reaches the speed of light, it causes this small thing to collapse into this infinitesimally small point called a singularity. The only thing that can indicate that the singularity is there is the presence of gravity at that point.
Mm-hmm.
So you've lost all the volume of your piece of matter, but you still have the gravity point. And this singularity is what's called a black hole. So Schwarzschild kind of discovered this and kind of had all the math to explain this based off of Einstein's theory, but it built very, very much so on the theory of relativity.
How common are these black holes?
So they estimate there's about one black hole there's at least one black hole in every galaxy.
That's awesome.
So yeah, so we have one.
Have a purpose.
Yeah, that's why they're really interested in them, especially because we have one in our galaxy. And when they try and look at like the relation of things in the galaxy to black hole, there's kind of a consistent ratio. So it seems like a black hole is really kind of keeping the galaxy intact in some way, shape, or form, but we don't really know how yet. The black hole that they photographed, they actually tried to photograph two black holes. They tried to photograph the one in our galaxy, but there were some interference issues. And then they tried to photograph one in the Messier 87 galaxy, which is 55 million light years away from Earth.
Wow.
So this is really far. And what they did, they needed to, in order to take a picture of this black hole, they needed basically a huge telescope to be able to do that. And we don't have any telescopes on Earth that can do it. But what they did is they linked together 10 different telescopes called the Event Horizon telescopes.
Divide and conquer.
Yes. So they had some in South Pole, in Chile, in Arizona, in Spain. So they were able to link together all these telescopes and tell them to take a picture all at the same time and like phase them together in order to get this picture.
Wow.
Because if you think about the way a telescope works, linking them together allows for a bigger picture to be taken, as long as you make sure that it's taking pictures at the same exact time.
Right.
Using these 10 telescopes, they could scan the cosmos with radio waves. And ultimately, when they were trying to understand how they could take this picture, they figured out that the resolution needed to take a picture of the black hole would be the resolution to see a bagel on the moon.
Oh my gosh.
So it's like very precise.
It's crazy.
And as I kind of mentioned, the photos that they took didn't actually capture the black hole itself. It was more the event horizon that surrounded the black hole. But that could show them the shape of a black hole.
Which mysteriously looks like a bagel.
It does. When they were able to take this picture, it took it about 2 years ago. They had everything kind of line up, and I think they had to make sure there weren't clouds over certain aspects. And they used this really cool atomic clock to line up the telescopes and how they would actually take the picture at the right time. And that one day produced 5,000 terabytes of data.
Wow.
So for the past 2 years, they've been analyzing this data, and they couldn't even send this data over the internet. They had to physically ship hard drives. So for the South Pole, they said they had to wait 6 months in order to ship these hard drives. So what you've seen recently is the piecing together of these images. And you may wonder, how do they piece these images together? They use this technology called interferometry, which is a technology that it's used to measure different waves, whether those be sound waves or light waves or different radio waves. A grad student at MIT, Katie Booman, was the one who put together this whole technology for the black hole specifically. And kind of the analogy they used of like analyzing this data, if you think of a lake and think about a lake that has maybe 5 different cameras all around it and then drop a pebble in the lake, if you want to sync up all those images from those 5 cameras once you drop the pebble, that's kind of how they had to do it for the black hole. So syncing up everything together at the exact same time and from different angles to get the picture that they wanted. So some of the cool takeaways from this research is that Einstein's theory of relativity has been proved correct again, which is amazing considering just how little we knew back then.
His brain was of average size, by the way.
Oh, really?
Yeah.
Going back to our brain video from 2 weeks ago. So yeah, it proved that he thought it would be round, and it was round. And it also showed that Schwarzschild was right in his calculations for the event horizon, because they used his calculations in order to determine where the event horizon would be. And we know that black holes are important for the galaxy, since almost every galaxy has a black hole. This is a really exciting finding, since we know that they're important, and maybe now this will give us a lot more information to be able to study them more. Hopefully, I think their next goal is to image the black hole in our own galaxy to get some more information on that, because we're obviously really interested.
Right, you can learn a lot just by observing, like how big is it, and
yeah, and maybe there'd be
different from other ones.
Yeah, exactly.